All right, finite math, unit 1, system of equations. So we're going back to, a little bit of algebra 1 and algebra 2. Remember, a system of equations is just when you have more than one equation, you're trying to solve for all the variables. Okay, so we do this once we have more than one variable to solve. Okay, we can't just do with normal algebraic solving of an equation. All right, so real world problem here. We have a coin gambling machine at the casino paid out $14.35 in a jackpot. There were 165 coins, that's very important, so is this number, in nickels and dimes, also very important. How many of each type were there? Well, first off, we want to name our variables. Now, a lot of people will just use X and Y and say X is nickels or X is dimes and Y is vice versa. But a lot of people like to, in real world problems, use letters that go with what they're talking about in the problem. Doesn't matter what you do. Okay, I like to use the letters that go with the story problem, usually. There are some exceptions depending on the letter. All right, now another important part here is the value of nickel and dimes. Actually, nickel is the only one that causes the problem. The most common mistake is people think nickel is 5, and they say 0.5. But 0.5 is really 50 cents, a half dollar. Nickels are worth 5 cents, 0.05, and dimes are 0.10. Now, when you do problems like this, okay, I like to have a value line. Whoops. A value line. I don't know why it's doing that. Let's see if we'll do it a third time. A value line, and actually I use personal preference. I usually do number first. A number and a value line. So on the top line, I'm going to put the number of things. So we don't know the number of nickels. We don't know the number of dimes, but we do know the total number of 165 coins. So N and D, even though we don't know them, represent the number of coins. The value we talked about, 5 cents for a nickel, 10 cents for a dime. You could put just 0.1 if you want, and $14.35. Now, if you think back to algebra and algebra 2, there's two ways to solve these problems. I can take this first equation and solve for either N or D by simply moving the other letter over. Very easy. So N would be 165 minus D. And then you would plug that in right here. It's called the substitution method. Okay? In these problems, I prefer to use elimination. And what I'm going to do there is I'm going to multiply one equation by a number so I have opposites. So in this case, I either want to get rid of my nickels or dimes. If I got rid of nickels, I'd want to multiply by negative 0.05, because when I add them together, they're going to cancel, or negative 0.10. Here's a hint: if you don't want to deal with a bunch of negatives, pick the smaller value, the smaller coin in this case. So I'm going to multiply by negative 0.05. All right? Now, when I get that, that will give me negative 0.05 N minus 0.05 D equals, whoops, no decimal there yet, equals negative $8.25. And then I write the one that we did not change, 0.05 N plus 0.10 D equals $14.35. Now, when I add these together, okay, the N's are going to cancel. Sorry, have a little technical difficulty here. And 10 cents minus 5 cents, because remember this was minus, is going to be 5 cents. Equal to, when I subtract $14.35 minus $8.25, I end up with $6.10. And then when I divide that by 0.05, I get 122. So there were 122 dimes. Now, if I would have gotten rid of the dimes by multiplying by negative 0.10, only difference is I would have had negative on both sides, still leading to a positive answer. Now, to find out the number of nickels, I just subtract that number from 165, and that gives me, hold on, 43. So the number of nickels is 43. All right, moving on. Now, this is a different type of problem because now we're doing a blending problem, a mixing problem. Now, you see we have peanuts and cashews, so I'm going to use P for peanuts and C for cashews. Okay. Now, very important here. It says the peanuts, I don't know, it's possessed today. The peanuts cost $3 a pound. The cashews cost $7 a pound. Okay. I want an 80-pound mixture costing $4 per pound. How many should I use in each? So this is a little bit trickier. Okay. So I still am going to have peanuts plus cashews totaling 80 pounds. Right? Now I'm still doing the total, the number and the value line, but there's one tricky extra step. My value, my cost of peanuts is $3 per pound. My cost of cashews is $7 per pound. What is the total cost for the mixture? Okay, it's not $4, right? It's $4 per pound for an 80-pound mixture. So we have to multiply those numbers. So this number right here is going to be 80 times 4, which is 320. Okay. Now we're at the exact same step as before. We need to multiply this one by -3 or -7. Again, I like to use the smaller number each time. It just makes it a little bit easier. I just like to avoid the negatives. So that's going to give me, I'm just going to write right underneath this one to save writing, -3p, -3c equals -240. The p's cancel. Okay. 7 minus 3 is 4. So that's 4c equals 320 minus 240 is 80. And then when I divide by 4, that's 20. So 20 pounds of cashews, subtract from 80, I need 60 pounds of peanuts. Right? All right, moving on. 2 more. A lot of numbers here in this one. Okay? The Zest Fruit Juice Company makes 2 kinds of punch, from apple juice and pineapple juice. So I'm going to, right off the bat, I'm going to use A and P. Sorry, not right off the bat. This gets more complicated. That is going to be important, though. The company has 142 gallons of apple juice, 108 gallons of pineapple juice. Each case of golden punch requires 4 gallons. Now, this is for the golden punch. Whoops. And 6 gallons of pineapple juice. The light punch, okay, the light punch requires 7 and 3. How many cases of each? Now, this one is, there's no value, okay? Well, there's no number, like just straight up number. We have the value or the mixture of each one. So this is kind of like the cashew problem, but both lines are value. All right? So what we need here is, we're going to say like G for golden and L for light. Now, here's one of the ones where I usually don't use the L because L looks like a 1. So we'll either use a cursive L, or even though we don't usually use capital letters, a capital L, right? Now, the 2 equations. We need to have an apple equation and a pineapple equation. Because we know apple juice, we have 142 gallons. And pineapple juice, we have 108 gallons. All All right, we know the number, the total number for each of those, the value of them. All right, now we just go back and fill in the letters and numbers. So for Golden Punch, it's 4 of apple and 6 for pineapple. And then for the light, it's 7, not Y, L, silly me, old habits, plus 3. Okay, so the apple is made up 4 golden and 7 light. Okay, and then the pineapple is used 6 for golden and 3 for light. Okay, now the reason we don't use A and P is because our total values are A and P. That's why we need the A here and the P here. Okay, so it's a little bit more complicated. Now in this case, I want to cancel my G's or my L's. So what number would I use? 24 and negative 24 or 21 and negative 21? It doesn't really matter. Okay, we can't make the 4 become a 6 or the 3 become a 7, so we have to actually change both. So I said 24, that's silly. We can go with 12 and negative 12. That's what I'm going to do. I'm going to do 3 here and negative 2 here. So that's going to give me 12G plus 21L equals, I don't know why I did that. Let's just be over here, times 3. So that's going to be 3 times 2 is 6, 12, 426. And then this one times negative 2, so negative 12G minus 6L equals negative 216. Now when I add straight down, okay, I need to do 21 minus 6. Okay, so that'd be 15. And then 426 minus 216 is 210. Okay, and then all I do is do 210 divided by 15. And I get L equals 14. Now, a little bit more work here. I have to plug the L in to either one and then solve. So I'm going to plug in the L, let's say right here. So 3 times 14 is 42. I'm going to subtract that from 108, which is 66. And when I divide by 6, G is 11. Okay. And last one, number 4. Tuition with room and board at Mizzou is $28,540. If tuition is 3 times room and board, how much is tuition? So I'm just going to use T for tuition. And you could use R or B for room and board. So we'll go with R for room and board. This one's a little bit easier. So we know that tuition plus room and board equals $28,540. It says, we're just going to translate verbatim. It says tuition is 3 times whatever room and board is. We literally just translate word for word, and that's our equation. T equals 3 times R. Now, even though earlier I said I like to use elimination over substitution usually, this one is already set up solving for T. So I'm going to take this 3R and just substitute it in right there, which gives me 3R plus 1R equals 28,540. Well, that's simply 4R equals 28,540. So I'm going to take 28,540 and divide it by 4. And that gives me 7135. So room and board is 7135. Now I have 2 ways of solving this problem. I know room and board is $71.35. I can multiply by 3. Or if I plugged it in here, I would just subtract that from $28,540. Doesn't really matter. You're going to get the same answer, but it's quicker just to multiply by 3. And that gives me tuition being $21,405. That's it.